So, for starting, we are going to put ourselves in some kind of scenario. You're a brand new partner using Odoo and you got a new client. You're waking up at 8 a.m. in the morning, enjoying your morning coffee. When you get a distress call from one of your clients complaining that his database is completely inaccessible and everything is slow. So the first thing you do as a good partner, you're going to open up your Odoo project and analyze the monitoring to understand what's happening, and you see this and everything is not working. You have your CPU that's bottlenecking, a bunch of concurrent requests. You have bad gateways of dropping HTTP requests. The response time is about 4 seconds, like nothing's working. The main idea is like when you see this is to understand what happened and how to identify what was the root cause of the issue. And I'm going to teach you at the end of this talk one superpower that's going to fix almost 80% of all your performance issue problems. Stay tuned. So we need basically two tools for the trade. One is the problem of traceability. Traceability is analyzing what happened at a certain point of time for a database, and usually you can access that from the logs. On Odoo you have access to all your logs, and also on-premise is the logs of your Odoo bin executable that's being output. On SH you have also additional logs like for the updates of the modules that occurred, the updates of the build, and also PG slow request, which is like every slow request that's logged for more than 30 seconds. The other tool you need is some kind of observability over your software, your server, and this is achieved with monitoring. If you're on-premise, you can install like Prometheus and Grafana to analyze when something happens with your database, and usually monitoring about hardware resources, and that's usually the main idea is to analyze when something happens. We're starting with observability, and we're going to go around each kind of graph, what they do, and what kind of answer they can provide to the questions you have. The main goal of the monitoring is not to understand what happened, but when it happens, because usually over a period of 1 week, if you have a performance issue, you need to pinpoint about what kind of hour, and because sometimes you have performance issue happening either in the evening, maybe it coincides with closing a post session, or when your employees are working on the database, it's a question of volume maybe. The first one is the most obvious one, is the CPU graph. So on Odoo SH, the CPU graph is cumulative, so when you see the 200 and 400%, it doesn't mean that you have your CPU going above and beyond and turbo boosting. It just means that for each worker, there's 100% CPU allocated to it. So for this graph, for example, it was a database with 8 workers. If you're peaking at 400%, it means like you actually peaked at 50% of your capacity. The colors are pretty straightforward. Green is everything that's Python side. Blue is everything that's on your database. Red is everything that's happened in an editor. So if you see the spike in red, it means that some administrator in the backend executed something in a Jupyter Lab or in the shell or in the terminal. And yellow is for crons and everything that's time-based automated actions. If you see a large spike in there, like maybe the problematic is of cron. This shows a relatively healthy database. Usually you would want maybe like 70% of green and 25% of blue. That's usually what a healthy database looks like. If you see something that's really odd, you see a big spike of blue, you can always open a ticket and analyze what's the root cause of the issue. For memory, usually that's the memory consumption of your container. For each worker, you have an attributed 2 GB per worker. It's not cumulative, so it means that if you buy 10 workers, doesn't mean you have 10, would be 20 GB to work for one request. It's 2 GB per request maximum. It shows you the general trend. So if you are, for example, importing for a long time, you will see it. What you don't see in the graph is because the graph is sampled at 5-second interval, if I'm not mistaken. Any sudden memory spike that happens from a specific use case, like you're, for example, signing an enormous document, usually architecture plans, for example, may spike your memory above the container. So you may have an out of memory without actually noticing it in monitoring. The red line you see is when a commit is pushed from your custom code. So if you commit something and suddenly you notice that after that red line, everything haywire, probably the issue is in your custom module. You can start from there and the investigation can be sped up. The request is pretty straightforward. It's the number of requests that's coming into your container. Usually you see like the errors and the rate limiting. So the rate limiting is usually the quantity of workers you have can help with sizing your database and accumulating the volume of customers you can accustomate to your database. Don't worry if you go above and beyond, like you create a sudden spike of customers, it's not an issue because requests are queued in case they cannot be processed. But in case when the queue is full, at that time, the Odoo SH platform will drop the request and you see a bad gateway error. In that case, we can investigate either what's the cause of the issue. Is it something just volume related, like you're being scanned by bot, you have ticket sale, like a Black Friday sale that sometimes accumulates a lot of customers from a short period of time. This graph is maybe the most interesting one. It's called the concurrency requests. It's mostly a question of bottlenecking and congestions. It also tells you about how you can size your database. So roughly, on average, you can count around 8 concurrent requests per worker. That's like your capacity. So if you see a volume of around, on average, for this database, we can say it's around the 40 mark. You would know that probably you would need 5 workers is like the good spot. You can have spikes that go above it, but as I said, requests are queued, so there's no issue there. If it's sustained, like as you can see here after 16 o'clock, you will see that there's a large wave of requests that are coming and are being installed. There's 2 reasons. Either it's a question of volume, or there's a question of one or few specific requests that were slow, and they are basically hogging the resources, and other requests cannot be processed. So this is a point to be investigated. The average response time is pretty straightforward. It's about telling you what's the average response time for a specific request. Know that back time in the monitoring data is aggregated, so you may lose spikes. So it's more interesting to check the average response time for the last 24 hours, where you have more sampling and you can actually spot if there was a spike in usage of your database and maybe something interesting was happening. For example, here we can see that at 16 o'clock, maybe there's something interesting to check at. For the traceability, once you know that roughly you have a timeline for this database, for example, we know that around 16 o'clock something odd happened, we can actually be interested of what actually happened. So I'm going to go over a class of errors you can see in logs that are related to performance issues, and the rest is mostly can be ignored. So warnings of how the registry could not like give you some warning. Usually you can ignore those. They are not the source of your performance issues, especially if like it's a general performance issue that you're not sure why is it happening, if it's happening sporadically, for example. We are going to talk about concurrency error and operational errors. So those are like the serialization errors, deadlocks, and also bad queries. So memory errors, so that is usually in the logs you will see a line that says process ID was queued because of a memory error, please check your custom modules. We are going to talk about how to investigate those and how to fix them. Dump stacks, those are the most interesting. Is like when you have a request that times out, actually Odoo will dump the whole process in the logs, and you can see at which point when the worker was queued, what happened, and what needs to be investigated. It gives you a rough idea what was happening when everything was slow. And we are going to mention some interesting ideas and advanced analysis you can do on logs with tools. So for the concurrency and operational errors, we have serialization failures, and this is not an issue. On average, if you have a few, it's not a problem. What's happening is like in PostgreSQL, in Odoo, we're running in a serialization mode of repeatable reads, which means that when a request starts, or a transaction starts, the transaction has a snapshot of your database with the data at point in time, what was happening. And if you have 2 parallel requests that modify the same record, for consistency reason, the first one that commits wins, and the other one is rollbacked. The one that rollbacked will roll back with an error that's called serialization error. If you see one or occasionally a few of those, it's not an issue. It's not a performance problem. There should be nothing to worry about. If you see a wave of those, like it's non-stopping, then there's something to worry about. Frequent times when you can see this kind of error for Odoo is like marking a discuss channel that is being read and the website visitors that are visiting your web page. So if you have a serialization error, also they are automatically retried up to 5 times. So if there's one, the Odoo server will restart it and retry the transaction, and usually the second time is passed, so there's no issue there if you see it occasionally. Deadlocks, those are interesting. So a deadlock is the concept of having 2 transactions waiting on the same resource, or waiting on like one transaction waiting on the resource that the other one acquired already. And in deadlocks in PostgreSQL, we actually scan those, and there's a graph detection between the transaction that's running, the lock that are required, and all transactions which kind of lock they are trying to require. And those are automatically detected and stopped and aborted. You see in the logs like deadlock detected. That's when Postgres actually detects deadlock. The transaction is rollbacked and it's retried. And usually the second time it passes, it's sometimes an issue of like you have concurrency requests that are going in the same time. The deadlocks that are more painful and more difficult to analyze, those are not in the logs. It's a deadlock between when in PostgreSQL one and the other in Python. And usually it happens when you open a second cursor in a transaction. If by any chance you have a request that comes in, it modifies some records, writes on something. When you write on a record, you acquire a soft lock. Then you open a new cursor, and somehow you do a write that implicitly depends on the result of what's been written in the current transaction. In that way, what happens is like Postgres will wait on the main transaction to finish to know if what I depend on needs to be committed or not, or has it rollbacked. For example, usually it's a unique constraint. If there's a unique constraint, Postgres needs to wait. Has the other record committed or not? If it had committed and my value that I'm inserting is the same, I should raise a constraint error. If not, if it's rollbacked, in that case I can insert whatever because the unique constraint is not going to be violated. But the Python is waiting on the second cursor, the transaction that's inserting, to finish. So in that case you have a deadlock that's actually not logged. And the only way to find it is like on the fly when you monitor your database with PG activity, or usually PG activity is like a good, nice way to see. You will see the blocking query and the waiting query. For analyzing those, if you know the flu to reproduce the issue, running the profiler, but you're at fixed sample time, will give you a good idea of where the code was passing by, and you can analyze which query were updating or inserting records. That's a good way to know which records were modified, which lock were acquired. But the one for PostgreSQL, if you see in the logs deadlock, if it's not repeated, it's like the serialization error. If it's not repeated, there's nothing to worry about. Bad queries, this is not a performance issue per se. It's mostly a question of like incorrectly constructed queries. Mostly, it's like passing a false value in a list of integer, for example, in a cursor. It's mostly a programming error. If you see those occasionally, it's not an issue. The only time it's a performance issue is like if it's in a cron, because a cron, if there's an exception and it has not committed, it's going to roll back. But if you roll back a cron, the next execution date of the cron is not being modified. If it's not being modified, it's going to retrigger itself automatically. And basically, you have a cron that calls itself all the time, fails, calls itself, then fails. And this is what's called a zombie cron. And you have basically something that's hoarding your resources all the time. For this, we introduced a new API that's called commit progress, which changes a bit of the way of thinking about cron processing. The main idea is like you specify a batch of records. Let's say you have some job, a long job that needs to process 20,000 records. You're going to process by 20, commit intermediately, and notify a progress, say, I've committed 20 of the 20,000 records I need to process. Then the cron will stop, and here cron trigger will be made to execute the cron again immediately. And so you may have a long-running job. This prevents acquire locks for a long time, actually processing the job on the fly and not waiting for the whole processing and then committing. And also, if your cron fails repeatedly for more than 5 times, now the cron is archived and you have a notification in the admin panel of your Discuss channel, I think, that tells you X cron failed more than 5 times, please go check it. But at least it will stop and prevent those kind of zombie crons to hog your resources. Memory errors are kind of funny to investigate because you just have in the logs that they happened, and that's it. Because you know the PID, but you don't know which request was making it. The only way to actually find them is like you have the symptom of having a notification that says that you've lost connection to your server, and then the connection was restored immediately after you did some flow. For example, you're posting a large invoice, you post it, it waits a bit, and then suddenly you get those 2 notifications and nothing happened. There was nothing changed, you cannot save the record, you cannot confirm it, nothing happened. 100% memory error most of the time. And so how to analyze those? It's simple. It's like if you have a flu to reproduce, we need actually tooling to analyze where the memory was used. The most popular one is like Memray, which is a tool made by Bloomberg. And it's actually state-of-the-art memory investigation for like a Python code. And so the main idea is you can use that, take your database locally, remove the memory limits of your Odoo bin, attach Memray to a process, run the flow, and then it will spit out a nice graph telling you, okay, which part of the code, like any profile, is using a lot of memory, and you can start investigating. Usually it's like prefetching, like excessive prefetching of HTML fields that have inserted like base64 images. What else? You have like reading large attachments, filtering. You have a lot of reasons, usually, that can be fixed. Also, we have a memory profiler this year, so I will be glad if you have any feedback when you use it. My colleague demonstrated a bit more yesterday how it's working. It's integrated in Odoo, which is really nice because it prevents you from downloading a dump locally. You can have at least a good first idea what's happening. Dump stacks, this is the most interesting part of analyzing for a performance issue. They happen when you time out, but they also happen when you have a quick quit event. So if you have a long request that hasn't timed out yet, and you don't know what's happening, you can actually spam on Odoo bin, kill -3, I think it was a third signal for sick quit, and it will dump, like Odoo will catch it, and it does not quit the operation, but actually dumps the stack trace in the logs. You do that a few times, and you have in the logs your stack trace that tells you where the code was being when it was like slow. And in the threads you have actually written what's the ID, so you have the user that made the request, the model, and you have your 3 numbers, the magic numbers for performance analysis in the logs. I'm going to come a bit later for it, but it's like the query count, the query time done in SQL, and then the rest of the time, which is assumed to be mostly Python time. And here we can see that at 900 seconds in Python time, this means like you timed out at 15 minutes. Advanced analysis, you have your log lines. What we care about is everything at the end. And in the end, you have the request, type of request, the status code, if it failed or like it was succeeded. And you have the 3 last digits, which as I said. And mostly the main idea of this is that because you have files that are extremely large, like a few sometimes it can be a few gigabytes for 1 day of logs on a large database, you need tooling to actually parse those. You can do a Python script, like inject them in some kind of database, or what there is installed on Odoo and also we use internally in the squad is called lnav.org for log navigation. And it's a little tool that parses the logs, injects them into an SQLite database, and then you can parse the logs and actually do queries on them. And one interesting part of it is like having this histogram, so you can actually have an idea of the frequency of the requests and the number of errors and warnings that are happening. And you can correlate those with the graphs from the monitoring you're observing, and having a rough idea, okay, I need maybe to go to 15 o'clock or 16 o'clock because I know, like I have this spike here, for example, we have at around 7:30, we have a huge spike of requests. Maybe we should check there what's happening, what was the IPs that are coming in. Another thing you can do in LNAV is run queries. You can actually have more ideas of an aggregate load of the database, what's happening. For example, if you have a client is complaining that everything seems slow, you can run a query that's just doing an aggregate on average on all the timing and the end of the request. You can multiply that by the request count, and you can assume this is called a load. And this load is corresponding to the amount, like the surface of the graph, or the CPU graph you can see. And for example, in this example, the first 2 requests is like amount maybe for like 80% of the load that was used. So you know that those are the requests that I need to investigate. You see that it's like quant web safe. Mostly it's an issue with merging quants and deadlocks. So you can proceed with the investigation with that. You can also do queries to filter, for example, the frequency of IPs that are coming in. If you have always the same IP, you can start to do a few analysis on the source of the IP. Who is it coming from? Is it a bot? Is it a service? Is it a VPN? To have an idea what's happening with your database. And that's it for this talk. It was a rough guideline. If you have any questions, I'm also at the dev zone usually for the performance issues. For the slides, you can hit me up with an email or any kind of questions you may have. And if you have any performance issue, in general, you can always open a ticket and someone from the team is going to analyze it and determine if the issue is from Odoo or from your custom code or an automated action that needs to be fixed. And usually we propose an idea for the fix, what needs to be done. Thank you for the talk.
Nice talk.
Thank you.
It was so good. We had 2 questions so far, I guess.
Yeah, people need to type them.
Yeah. So, but we have one in V19. Zombie crons are automatically deactivated. Is there anything in place to notify us of the deactivation?
Yes. So when you have a cron that's been disabled, in the discuss you have a notification for the admin account, so you need to log in as an administrator, and you have a notification that says like cron X, the name of the cron was disabled because it failed 5 times, and you can start investigating why it failed. Is it like a consistent issue with like just a programming error, like a syntax error, or is it more like problematic like a lock or something?
And is there any pre-cooked Grafana setup or dashboard for on-premises systems?
Sadly, no, we don't have those, but the thing is like it will depend mostly of your deployment, and so we cannot know in advance what kind of deployment you have. For example, we have a lot of on-premise clients that use Kubernetes for like, they spawn multiple front ends with one big database backend on multiple machines. So it depends roughly on your setup, and that's mostly either your VPN provider may have some kind of Grafana that provides you with some CPU or request logging. Or you do them yourself, you consult with like a DevOps engineer to set that up. But sadly, we don't propose them for like, maybe we could, it's like feedback to ponder on, but for now we don't have such.
Follow up of the previous questions. Auto deactivate is only on Odoo SH, or is it something for
It's
on-premise?
standard, like the deactivation is standard for on SaaS, on SH, on-premise, like normally it's like standard code. You can search for like commit progress, the function name, the documentation is there. That's how cron long-running cron should be written in that way. And the main idea is like if you commit for small batches, when you commit, you free the locks that you did updates on the records before that. So usually the database runs more smoothly because there's no long transaction that's hogging logs that for records that it already processed.
And where can we see the lnav config for Odoo?
The lnav config is actually pretty simple. If you want to just send an email, I'll send it to you, but it's just a JSON file that you specify the request how to be parsed, like the log line, how it will be parsed, but it's pretty straightforward. You can do one yourself, but if you won't have one ready, we have one, and so you can just send me an email, I'll send it to you, no problem.
All right. I don't know if you want to wait a little bit more.
No, if it's done, it's done.
Okay. Thank
Thank you. Hope you liked it.